Today's the day that you learn trigonometry for the first time. There are three trigonometric functions that I'm going to teach you. They're called sine, cosine, and tangent. And the basic idea is that it involves right triangles, and there's actually a relationship between angles and the sides of the triangles. So each ratio will relate an angle to the measure of two sides. Before we start, it's important that we are able to identify what the sides of the right triangle are called. Hopefully you're pretty good at identifying which side is the hypotenuse by now. It's the one across from the right angle. On this bottom triangle, the hypotenuse is the one across from the right angle. Now when we talk about opposite and adjacent, that all depends on what angle you're standing at. We'll always be either standing at one of the two acute angles. So I see on this triangle the x angle is labeled. So we would say that the side that's way across from the x, that would be the opposite side. And next to that, not the hypotenuse, but the other side, that's the other leg that's next to that, is called the adjacent side. Adjacent just means next to. So if we were looking at this second triangle, we've already found the hypotenuse. If you're standing at this angle, which by the way, isn't this a 45, 45, 90? So x is equal to 45 degrees. Which side is opposite? The one that's all the way across. That side doesn't even touch the vertex of the angles. So that would be my opposite side for this one. And the other leg, the other 6, is called the adjacent side. It's important to name those sides because the three trigonometric ratios that we will learn in trigonometry are relating two sides, like I said. They relate the angle and two of the sides. And we identify them as opposite, adjacent, and hypotenuse. This little box is something worth memorizing because it tells us what to stack up, what ratio to make for each of those three trig functions. Now you'll see that those are abbreviated. I call them sine, cosine, and tangent, but their abbreviations look like sin, cos, and tan, and that's how you'll see them on your calculator too. So how do people remember that sine of the angle is the opposite over the hypotenuse and cosine of the angle is the adjacent over the hypotenuse? Well, there's this little memory trick. We write it Sohcahtoa, and anybody you talk to about trig will be able to recite Sohcahtoa to you, because sine means the opposite over the hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. It's a nice quick way to remember the three trig ratios. I have three triangles down here, and I don't know if you noticed, but these are all similar triangles by side angle side. They've all got the right angles, and then these two sides on the sides of the right angles are proportional on each one. That's not super important right now. What I want to do is I want to try to set up our first trig ratio for this top triangle. So I can see that they're indicating that this is the important acute angle. They have the Greek letter theta, which is often used as an angle variable. And I can see that the hypotenuse isn't even labeled, but I have numbers on this opposite side and on this adjacent side. So what I want to do is I want to figure out which of these three involves an opposite and an adjacent. Do you see that the TOA has the O and the A? So what that tells me is that when I set up my trig ratio, I'll want to use the T. I'll want to use the tangent ratio. And the way I say this is that the tangent of angle theta is equal to the opposite over the adjacent. If you wanted to reduce that, you could. Usually I just leave it as 3 over 9. Let's try the second triangle. So here's my theta. Again, the opposite and the adjacent are labeled. So again, I can set up a tangent ratio. Tangent of that angle theta is equal to 4 over 12, opposite over adjacent. That one actually also reduces to 1/3. And finally, this bottom one, for this angle theta, if I set up the tangent of that theta, I would get the opposite over the adjacent. Tangent of theta equals 5 over 15, which you might notice also reduces to 1/3. And the reason I did these 3 examples is because I want you to notice that all of those ratios are the same, and that's because, remember these were similar triangles. On similar triangles, all the angles are congruent and the sides are proportional. So this angle theta is the same angle theta in every triangle, so we should expect that the tangent of that angle theta always gives us the same answer, regardless of which triangle we'd be looking at. I did some math on this, and I actually figured out that that angle theta would be about 18.43 degrees. I want us to be able to type in tangent of theta. So we're going to type in tangent of 18.43 degrees and see if it really equals 1/3. My sine, cosine, and tangent buttons are right in the middle of my calculator. So this tan is the abbreviation for tangent. And if I type in the tangent of theta, or the tangent of 18.43 degrees, it will tell me the ratio. It puts it as a decimal. It won't put it as a fraction. But what is 1/3 as a decimal? It's 0.3 repeating. So I get the 0.3, 3, 3, and really they should all be 3s, but that's a rounded value. I want you to try this on your calculator right now. On some calculators, you have to type in the 18.43 and then push the tangent button, but we should all be getting 0.333. If anybody's getting a negative number instead of 0.333, I think I know the problem. You know how this is 18.43 degrees? Somewhere on your calculator, you should see a mode or a settings button. And you can see that my mode is already set to degree. On some calculators, it's abbreviated DEG. But I'm putting that angle in as a degree, so it's important that I have that highlighted. If you need help figuring out your calculator, let me know. But as long as you're in degree mode, we should all be able to show that tangent of 18.43 is about 0.333. Today we're just setting up these ratios. The next time we will talk about how we can actually solve problems using sine, cosine, and tangent. But for today we're just trying to get our heads wrapped around these functions. I'm going to start with this first triangle that has this angle A over here, and it has a 6 and an 11. First thing you want to do is figure out, are those hypotenuse, adjacent, or opposite? And I can see that the hypotenuse doesn't have anything labeled on there. The 6 would be the one way across from angle A, so that's the opposite side. And the 11 is right next to it, so that's my adjacent side. And again, this is one of those setups where I have an O and an A that are labeled, which makes it a TOA setup. The way that I would write that then is tangent of angle A is equal to 6 over 11. And that's all we're doing today, is just setting up our trig ratios. Let's try another one. This one's a little different because angle B is the one that I wanted to focus on. I can see that across from the right angle is my hypotenuse, and that 10 is across from the B, so that's my opposite. Which one of the 3 trig functions uses an H and an O? It's looking like so. So I'm going to use the one that starts with an S. I'm going to use sine. Sine of angle B is equal to opposite over hypotenuse 10 over 14. That's how that angle is related to the ratio of those 2 sides. So I'd say all people learning trig write Sohcahtoa at the top of their page, because that's going to be the key for all these right triangles. Here I've got angle B. It looks like my hypotenuse is labeled, and the side right next to B, which is the adjacent. So this is my first one where I had an H and an A. You can see that this abbreviation has the H and the A, so I'm going to be using the C, the cosine. Cosine of angle B is equal to adjacent over hypotenuse. Cosine of angle B is 7 over 15. We're just going to keep practicing. I've got an angle A down here. Notice we're always using one of those acute angles. We should be able to see where the hypotenuse is. That's the one across from the right angle. And this time it looks like that 4 is the adjacent side, since this one over here would be the opposite. I have an H and an A again, so that's my C, my ca. So I'll say cosine of angle A equals A over H, 4 over 5. Here we've got angle A again. I've got a hypotenuse, and this time they gave me the opposite side. So I'm looking for one that has an H and an O, and that is my SO. So I will write sine of angle A equals O over H, 2 over 6. That order is important. Last one, we're up at angle B. If we're at angle B, then the 8 is the opposite, and the 3 is the adjacent. No hypotenuse on this one. So an A and an O show up in the TOA. So I will be using the T1, the tangent. Tangent of angle B equals O over A, 8 over 3. So this first part of this lesson is just to get you used to setting up these trigonometric ratios, these trig ratios. We are on our way to learning some trigonometry.